Okay, welcome again. Uh, an exercise was given in your last period to identify different categories of materials, that is, metals, ceramics, or polymers. These materials are to be identified by which are around us, that is, in our daily walk of life. Whatever material you come across, you have to classify them as metals, ceramics, and polymers. This is a beautiful exercise. This will definitely help you to add to your knowledge simply by observation. So take this exercise seriously. Okay, now let us go ahead. Now we want to go in more depth about this subject, that is crystal structure. Whatever materials, metals, ceramics or polymers you observe around you, see, every material is different in nature. It has differences chemically. It has different physical appearance. It has different surface texture. It has different mechanical properties. It behaves differently in corrosive environment. See, lot of differences are there. Why these differences exist? This is the biggest question. Every material behaves differently, either mechanically or physically, electrically or thermally. Why this difference exactly exist? The reason behind this is every material is different at atomic level. That is, materials are made different because their atoms are different. Now let us try to understand this smallest element of an atom, smallest smallest element of an element, that is atom. Yeah, you might have studied Bohr's atomic model. You can see from this picture. This is the model suggested by Bohr. Niels Bohr was a scientist. He suggested this model that a nucleus is there which is comprising of protons and neutrons, while electrons are orbiting around this nucleus. The way our solar system model is, that is, sun is at the center, earth, Saturn, all these satellites are orbiting around sun. Exactly in the same way, the atom model is suggested by Niels Bohr. Nucleus, which is comprising of protons and neutrons. Protons are positively charged particles. Neutrons does not have any charge. While electrons, which are negatively charged particles, they are orbiting around this nucleus in either circular or elliptical orbit. This is the model. Everybody have already understood this model. Okay. See, the point is why we are studying at atomic level, because we want to differentiate these atoms of different elements. Means, how is the atomic structure in ceramics? How is the atomic structure in metallic elements? Why ceramics are harder and brittle in nature? Why metals have good ductility before fracture? Why there is electrical resistance provided by polymer material? We want to answer these questions. All these questions are answered in this atomic model. Why materials have different behaviors under different conditions? All these questions are answered by this atomic model. Now let us focus on this atomic model. See, as I have said already, protons are positively charged, Neutrons are, there is no charge to the neutrons, while electrons are negatively charged. Protons and neutrons, see, it is further detailed out here. Protons have some mass too. Neutrons have a little bit higher mass as compared to protons. While the charge of protons and neutrons is identical, but mass of electron is far, far, far lower than protons. That is 1 by 1800 times less than protons. Electrons have same charge, but the mass of electrons is very, very low. That's why nucleus is very much massive as compared to electrons which are orbiting around this nucleus. And one more thing which you might have already studied, the atomic number of any element, whether it is metallic or non-metallic, atomic number of any element is equal to the number of protons. See, where this atomic number is, you might have heard about this periodic table. You try to recall that periodic table. The elements are arranged in increasing order of atomic number in periodic table. We are going to learn about that periodic table too. This is fundamental knowledge, and everybody must refresh, recall, or retrieve this periodic table knowledge. Now, to sum up or to end up this, the electrons are spinning on their own axis. Electrons are not only orbiting, like Earth spins about its own axis as well as orbits around Sun. Exactly in the same fashion electron behaves. Electron spins or it rotates about its own axis as well as it orbits around neutron. Now, how these electrons are arranged? The electrons are arranged in number of shells and subshells. Now, what is this electronic configuration? That also we are going to learn. Now, to recall, you have to recall this periodic table. All these elements are arranged in increasing atomic number order: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. See why they are arranged in this fashion. Let us try to learn about this. Elements of any given family which show the similarity in chemical properties are arranged in same column. That means these vertical columns, all these elements have identical chemical properties. You can distinguish this last right column. You can see this last right column. Helium, neon, argon, krypton, xenon. All these are inert gases. Why they are called inert gases? They are chemically inert. They never react with any other metal. While this first column, hydrogen, lithium, if we refer for the electron configuration, that is how electrons are arranged in shells and subshells, you will always observe that the last shell always contains only one electron. In the similar fashion, this next column has two valence electrons. Like this way, all these identical electron configuration elements are arranged in columns. The elements in each horizontal row or period increases from left to right in atomic weight, atomic mass, atomic number, and atomic weight. These are the three important parameters on the basis of which these elements are to be distinguished. Atomic number is nothing but number of protons. Atomic weight is nothing but the entire weight of that atom is concentrated in the nucleus. That is, weight of proton and weight of neutron is nothing but atomic weight of that particular atom. It is not that all the atoms have same number of neutrons. It is likely that some atoms have different number of electrons. These atoms which have different number of neutrons is called isotopes. The average atomic weight of isotopes is regarded as the atomic weight of for that particular element. See, this is another important. The electrons in unfilled shells are known as valence electrons and are largely responsible for chemical behavior of element. If we refer for electron configuration, for example, sodium is sodium element. Sodium has 11 electrons. The electrons are arranged in different shells and subshells. S, P, D, F, these are the shells. Thus, for sodium, 11 electrons are arranged as 1s2, 2s2, 2p6 and 3s1. The outermost shell has only one electron. 3s shell, which capacity is to accommodate for 2 electrons, it is having only one electron in its outermost shell. This one electron is called valence electron, and this valence electron or the number of valence electrons describe its chemical behavior. Okay, the metals on the left side of periodic table constitute about 3/4 of the element. Means 3/4 of the elements are located on the left side of periodic table. Some of the elements are metalloids. Metalloids means they neither be treated as metals or non-metals. They have properties in between metals and non-metals. That's why they are called metalloids. They are carbon, boron and silicon. You can clearly see this on periodic table. Some of the elements are non-metals. Some of them are inert gases. Let me show you this periodic table. See, this vertical column has only one valence electron. This right side column has no valence electron. That's why they are treated as inert gases, which are chemically totally inactive one. While these middle ones are metals. This diagonal axis, all these elements are, you can see this. These are metalloids. How many natural elements are there? 102 elements are there. All these natural elements are arranged in this periodic table of with increasing atomic number or atomic weight. You must remember this periodic table throughout your life. See, chromium, molybdenum, tungsten, they are placed in the same column. What is the importance of this? Tungsten is very rarely occurring element. मतलब natural occurrence is very low. फार कमी प्रमाणात ते निसर्गामध्ये सापडतं. पण टंगस्टनच्या, मॉलिब्डेनमच्या आणि क्रोमियमच्या प्रॉपर्टीज ह्या जवळपास सारख्या आहेत. मग जिथं टंगस्टन वापरता येत नाही, जिथं अवेलेबल नाही आहे टंगस्टन, तिथं मॉलिब्डेनम वापरलं तरी चालतं. मॉलिब्डेनम जिथं अवेलेबल नाही तिथं क्रोमियम वापरलं तरी चालतं. This periodic table was constructed by Mendeleev. तुम्ही मराठीमध्ये शिकला असाल मेंडेलिफची आवर्त सारणी. This is the biggest contribution by Mendeleev. Okay. Let us stop for this. In next period we shall speak something in more detail.